So here we go. So why do we have logarithms? Right? This slide, the whole purpose of this slide was to explain that a logarithmic function is the inverse of an exponential function. Why do we need inverses? We need inverses to be able to undo things, right? When you have the addition of some number, it has an inverse operation of subtraction. So subtraction and addition, they undo each other, right? Arc sine and sine, they are functions that undo. When I compose them, they presto changeo, they're both gone. So we needed to have a function, okay, and they decided this in the, whatever it was, 16th century, to be able to solve for x, right? Very, very classic problem, 16th century Germany, okay? So they looked at this and they said, we got to be able to solve for that. How do we undo this fact that there is an exponent, or excuse me, a variable in the exponential level? And that's what logarithms do, okay? When you take the log of both sides, you create a single layer of a problem that you can then solve for x. You bring that x out of the exponential level. That's the undoing of that exponent. So we have logarithms in order to help us understand the math behind this. A different interpretation of this statement would be this. This is, in other words, a translation from exponential form to logarithmic form. Okay. A logarithm is, this is hard for people to understand, but a logarithm is an exponent. Okay. It's the inverse of that exponent, but it is an exponent in and of itself. So when you interpret this, when you look at this and I say, what does this mean? When I say, when you look at this and you say, what does this mean? You're saying 3 raised to some power has to be equal to 81. Right? I think everybody understands that notation. What does this mean? This means the same exact thing. But the way that we have to read it, it's a bit odd. We're basically saying that 3 raised to the x power is equal to 81. This is how we interpret it. We interpret it the same way, but the way that it's written, okay, can change. And it depends on what you're doing. When you're in this universe of mathematics, it depends on what you're actually trying to accomplish, what way you should write it. All right, like the way that this is written right here, I don't know what to do with that. Well, I know what to do with that. But I'm saying when it's written like this, we're saying, and I'm going to write this down. I'm going to say the basic format of any logarithm is a to the power of x is b. There exists some power of a that will produce an output of b. The base of the log is typically not the input, okay? This is the input to a logarithm. These are the input values. The domain values are plugged in here, right? These are your output values. So maybe I should have chosen x and y. I sort of chose 4 values to put in those places, right? The output of a logarithm is the exponent, okay? The input of the logarithm is the power of this raised to that exponent, all right? Questions on how to interpret logarithms, all right? Having the ability, having the wherewithal to switch between these two forms is going to make you stronger when you're solving for some of these. Click off.